Now let's talk about arithmetic operators. So arithmetic operators are used to perform common mathematical operations, and you should be familiar with most of it already. So the plus operator is the addition, and as you can see in example, 5 plus 6 yields 11, and subtraction, 5 minus 1, 5 minus 6 yields minus 1. Multiplication is defined by the asterisk. So 5 times 6 yields 30. And division is, if in division, if both values are integers, it will yield an integer. It will remove the decimal part, or if any or both of the values are double, it will yield a double value. So 10 divided by 4 is 2.5, whereas here 10 divided by 4 is only 2. So modulus is a very important operator in all programming languages. So 5 mod 6 will yield 5. So it basically returns the remainder from this division. So, and then 10 mod 3 will yield 1. So you can fit 3 3's in 10, and the remainder is 1. It will return the remainder. And finally, the increment and decrement operators, plus plus and minus minus. So in this example, so if x is 5, x plus plus will return 6. And again, if x is 5, x minus minus will return 4. So let's see this in the examples. So let's start comparison and logical operators. So last lecture we did see the comparison operators, less than, greater than, less than or equal to, greater than, equal to, and not equal to. So let's talk about the logical operators, and that compares two Boolean expressions to each other, or can compare two again Boolean expressions. XOR is exclusive OR, and this is the short circuit for OR, and this is the short circuit for AND. And we'll see those examples. We'll see what that means in later on. So an exclamation mark is for NOT. So let's see a truth table on this. So the relationship between two Boolean values, let's say P and Q. If P is true and then Q is true, P and Q is also true. If any of them is false, and P and Q is false. So in case of OR, if P is true and Q is true, P or Q is true. And if any of them is true, which in this case of this true, false and false true, will P or Q will be true. If all or both are false, P or Q will be false. And in exclusive OR, exclusive OR is looks to one or the other, but not both. So if P is true and Q is true, it will return false. If one of them is true, so P is true, Q is false, or vice versa, it will return true. If both of them are false, it will return false. And finally, the NOT operator basically negates. So it's a single operator. It's only need one expression. So if P is false, if P is true, it will return false. And if P is false, it will return true. So let's see this in examples. All right, let's work on another Java program where we can test our logical operators. So I'm going to save this as logic demo.java. Okay, so I can say class. You already should be very familiar with this class logic demo, And I also want to add a comment line. I just copy and pasting, so I don't want to take your time typing. Right, so main. Okay, so let's start with an integer, let's say I and j. So we already learned that we can actually define or declare two variables in the same line with one int. Then I can initialize them. I'm going to assign 10 to I and maybe 11 to j. Okay, let's do some practice on the logical operators. So first, let's do some comparison. So PL, so I want to say the outcome of, let's say, j greater than I. So this will be, let's also make sure that we know what we're doing. J greater than I is, or let's just keep it that way. Yeah. Okay, so go ahead and test this. I'm gonna say Java C logic demo.java. Okay, one problem. We should put them in parentheses. So Java confuses the plus sign with this, so better if we, yeah, I think we're good. So j greater than I is true. I'm gonna keep them as I and j. So, and then I'm gonna copy this just out of laziness. If I say j is less than I, what would be j less than I? So we keep in mind the values of I. Maybe we can just print them for the user. Okay, so j less than I is false. J greater than I is true. J less than I is false. What else we can do? We can, how about equality? Let's check for equality. And the first one is just to print this. The second one is to actually make this statement or expression work and then return a result. Here we go. J equal to I is false. How about one more? J is not equal to. This is not equal to sign, and this is how you write it. So I actually do wanna print. Just wanna see. I want the user to know what the J is and what I is, and equal to space plus J. So it's just a better output. One problem. Okay. What line is this? This is line 14. Okay. Not equal to is the other way around. Not equal to. Okay, so here you go. Now we know. Oh, one more thing. Just make it. I just want to make sure it looks nicer. There you go. So I is 10, J is 11. Now we know that we can know what to compare. So 10 is or 11 is greater than I is true. 11 is less than I is false. 11 is equal to I is false. 11 is not equal to 10 is true. Okay, so that's how we could use the comparison operators. Now I want to do Boolean operator. So I'm going to create a Boolean B, let's say B1 and B2. All right, so, and then down here, I'm going to say B1 is set to true, just like this. and then B2 is set to what? False. Okay. So what can I do is I can say PL, then I want to write what I want to compare. I want to say B1 and B2. That's logical operators. B1 and B2 is, the way we compare is we can say B1 and B2. Okay, let's see this. So clear, so we can see start from the top again. Oops, here's what I want to do. Okay, so B1 and B2 is false. Why? Because for the end to work, they both must be true. And you might ask, what is the difference between single ampersand and double ampersand? Single ampersand is the actual one. It compares both. It evaluates both and it compares them. And double ampersand is the shortcut, which means if this is false already, we're not going to bother to check this one because it's not going to change the outcome. That's why. So it's more common to use 2 ampersand than 1. So let's do an OR. OR is this. Okay, 2 vertical slashes. So B1 or B2 is true because at least one of them is true. And lastly, or maybe a few more, let's say not B1. So I want to know what not B1 is. Not B1 is not B1. That's how we could do. So we know what B1 is. We know it's true. And now we're going to see what is not true. Not B1 is false. Okay. So you can go ahead and use them inside if statements as well. What we could do that, what I really wanted to do, I wanted to make sure that we actually just single-handedly evaluate this instead of doing an if statement. So every Boolean expression is also an expression, and it will always evaluate to a single value. In case of Booleans, they always evaluate to true or false. And the difference between comparison and logical is comparisons can compare any values. However, the Boolean or the logical operator must compare 2 Booleans. So they must be true or false. You can also do one more thing I'm gonna do just to show you what I. So we can use AND, but we don't want to compare 3 and 5. This doesn't mean anything. What we want to compare is we want to say 3 is, or let's say we have a 10 I, so or J. Let's say we want to say J is greater than 10 and J is less than 20. So would that be true? Depends on this both. This itself is a single expression. However, this single expression consists of 2 separate expressions. This one returns true and this one returns true. True and true is true. So let's finally take a look at this one. So true and true is true. If any of them is false, let's say is J greater than 15 and less than 20. Basically, we're oops, not this one. So greater than 15. So I want to see whether J is between 15 and 20, right? So is it? No. So let's verify that. So it's false. Why? Because this one is false. So this being 2 ampersand means it's a shortcut AND operator, is because, which means that if this is false, we find at least one false, so we will not change. Yeah, we will not. Java will not check this one. It will just move on from this. One of the important reasons why we want to have this is, let's say we want to divide I by j. Okay, I by j. Here's what we want to do. If we want to say, here's what I want to do. If j is not equal to 0, so j should not be equal to 0. Okay, and then I can say ji divide by j is equal to something. Let's say 2, just making up. So why this is important? Here, a little typo. So this is a comparison operator, which means it's going to divide this and then see whether the result is 2 or not. However, there's a flaw here. If j is 0, the program will crash. So if we don't want the program to crash, we can say j not equal to 0. If this is true, then move forward and do that. So otherwise, in a single end, this program will crash. Okay, let's try both ways. So this is false, which don't really care the result, but what I want to do is I want to set j to 0. Okay, then I'm gonna try again. If j0 program didn't crash because we exit out from here. However, if we had a single ampersand, and I'm gonna try. Okay, there you go, program error. Okay, so and this video took longer than expected, but this is what I want to show you so far.